Hello, my name is Gabe. For this problem, we're asked to find the standard form of the equation of an ellipse, which has the center at the point 1, 4. We know that A is equal to 2C, and it has vertices at the points 1, 0, and 1, 8. So let's go ahead and let's actually sketch a real quick graph of what our ellipse is going to look like. This will help us in the long term. So the center we said was the point 1, 4. So let's go ahead and just plot that point on our graph. And we know that we have vertices at the point 1, 0. And we have vertices at and we have a vertex at the point 1, 8. So now, something that we want to note is we want to note that these vertices happen at the endpoints of our major axis. So what that tells us is that our ellipse can't come way over here and way over this way. So it's going to have to be longer in the vertical direction than it is in the horizontal direction. So if I just wanted to sketch maybe what our ellipse will look like, we may have something which looks like this. So again, that's just a really rough sketch, just to have an idea of what we're talking about here. All right, so since our ellipse is going to be vertical, the equation that we're going to want to use is going to be x minus h, this quantity squared, over b squared, plus y minus k, quantity squared, over a squared, is equal to 1. And the reason that we're using this equation is, as I said, our ellipse, the major axis of our ellipse, is the vertical axis. So that's why we're associating a with our y terms, or with our y values. All right, so our goal here then is to find h, k, a, and b. Now, h and k are pretty easy to find because those come straight from the center of our ellipse. So we know that the point hk is the center, and in this problem, that center is the point 1, 4. So what this tells me is that h is equal to 1 and k is equal to 4. Now the next thing we'll want to notice is that, well, how can we find a or b? Well, we know the length of the major axis is 2a, so half that length is a. So looking at this problem, we see that half the length of the major axis is going to be 4. So what this right here tells us is that a equals 4. So now we have h, k, and a figured out. All that's left is to find b. So we'll have to use this last piece of information to find b. And what this tells us is that a is equal to 2c. Well, how does knowing how c relates to a relate to b? Well, you'll want to recall that c is related to a and b by c squared equals a squared minus b squared. So this shows us how c is related to both a and b. So since we know that a is equal to 2c, we can actually use that information to solve for c. So if we know a equals 2c, well, we really know what a is. So we'll substitute 4 in for a, and we have that 4 is equal to 2c. Well, dividing both sides of this equation by 2, we arrive at the point c equals 2. So now we have a and c solved for. We can substitute those into this equation to solve for b. So c we said was 2, so c squared is 4. A squared is equal to 16, since a was equal to 4. And we're subtracting b squared. Now here we can imagine rearranging this a couple different ways. Let's first add b squared to both sides of the equation. So we have 4 plus b squared is equal to 16. Now we can subtract 4 from both sides of the equation. And we have b squared is equal to 12. And finally, solving for b by taking square roots of both sides, we have b is equal to the square root of 12. Here, we're only concerning ourselves with the positive value, since really we're talking about kind of a distance here. We're talking about half the length of our minor axis. So the square root of 12 we can rewrite as 2 times the square root of 3. Really, when it comes time to writing the standard form of the equation, it'll probably be easiest to use the square root of 12, but if we were asked to graph this, we might want to use this 2 times the square root of 3. So at this stage, we know what h is, we know what k is, we know what a is, and we know what b is. Now we just need to substitute this back into our equation. So the standard form of the equation of our ellipse is going to be given by x minus h, which is 1, divided by b squared. Well, we know that b was the square root of 12, so b squared is 12, plus, this quantity is squared, so we have an x minus 1 squared divided by 12, plus y minus k. We found k to be 4. This quantity squared divided by a squared. We found a to be 4. So 4 squared is 16. And this is equal to 1. So the standard form of the equation of our ellipse is given by x minus 1 quantity squared divided by 12 plus y minus 4 quantity squared divided by 16 is equal to 1. Thank you.